Dear students, today I would like to talk about the topic electronegativity and anomalous properties of second period elements. It is in Unit 3. It is in Unit 3. So far, we have learned electron affinity, right? This is the last chapter in Unit 3, electronegativity and anomalous properties of second period elements. Let us discuss the topic. First one, electronegativity. Second one, variation of electronegativity along period. Third one, variation of electronegativity along first group. Fourth one, anomalous properties of second period elements. Then last one, periodic trends and chemical reactivity. The first question, define electronegativity. Define electronegativity. Electronegativity may be defined as the relative tendency of an atom in a molecule to attract the shared pair of electron towards itself. Actually, the tendency of an atom in a molecule, so maybe halogens, fluorine, chlorine, bromine, iodine. So group number 17, we can find the halogen, fluorine, chlorine, bromine, iodine. These are the halogen have the tendency to attract the shared pair of electron with hydrogen. So for example, the fluorine is bonded with the hydrogen, chlorine is bonded with the hydrogen, bromine is bonded with the hydrogen, then iodine is bonded with the hydrogen. Now, among the halogen, fluorine, chlorine, bromine, iodine, the electronegativity have much in fluorine, because this fluorine, after making the bond with the hydrogen, it attracts the shared pair of electron in the bond towards itself. So when we compare fluorine, chlorine, bromine, iodine, fluorine is more electronegative. Second one, chlorine. Chlorine is more electronegative than bromine. Bromine is greater than iodine, right? So top to bottom, the electronegativity decreases, right? It is very important. Three more question. The statement and examples we should write. So second question, which formula is used to find electronegativity by Pauling scale? So we can find the electronegativity by using this formula, but this formula does not have any unit. So in the last class, electron affinity, ionization energy and all we can measure by the unit kilojoule per mole electron volt, but here by measuring electronegativity there is no unit. Why? Because it is compared with the hydrogen. The atom is compared with the hydrogen, by which we can find the electronegativity. So here in this formula, electronegativity symbol A minus electronegativity symbol B equal to 0.182 root EAB minus, so within bracket we should write EAA into EBB, close the bracket, power 1 by 2. Power 1 by 2. Here, EAB, EAA, EBB are the bond dissociation energies of AB and A2 and B2, right? So E means bond dissociation energy. For breaking the bond, how much energy is required? That is called bond dissociation energy. Here, the A atom may be electronegative atom. B considered as hydrogen. B considered as hydrogen. Okay. Now we see the variation of electronegativity along period. Variation of electronegativity along period. So in the periodic table, left hand side to right hand side, what are the variation occurs? We will see. Left side, the P block allowance, I am going to explain with this. Boron, then carbon, nitrogen, oxygen, fluorine, then neon. The boron atomic number 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. So left to right, atomic size decreases. Atomic size decreases. Why? Because 5 proton attract 5 electron. In boron, suppose you take neon, 10 proton attract 10 electron. That's why the attraction force is maximum present in right side. That's why size gradually decreases. Okay. Now the electronegativity is indirectly proportional to the atomic size. So left to right atomic size decreases, the same left to right electronegativity increases, because tendency of atom in a molecule to attract the shared pair of electron towards itself. Nuclear charge also increases left to right. So in a statement, in a period means what? Left to right or horizontal, we can say that. In periodic table, electronegativity increases on moving from left to right. This is due to the reason that nuclear charge increases whereas atomic radius decreases. Right? So left to right, electronegativity increases, atomic size decreases. These are the variation. Now it is mentioned in graph. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So left to right, the elements are given in the periodic table. As per the periodic table is given. Okay, the x-axis atomic number, y-axis electronegativity. So left to right electronegativity increases. We can get a straight line. So variation of electronegativity along first group. Variation of electronegativity along first group. So just now we have seen the same variation of electronegativity along period. Now we are going to see the group. Group means what? In the periodic table, column or vertical. Okay. Here, alkali metal alone I have used. For example, lithium, sodium, potassium, rubidium. Right? Top to bottom, atomic size increases. Atomic size increases. extra shielding in each orbital increases. Atomic size increases, shielding increases. Now the electronegativity top to bottom decreases. The tendency of atom in a molecule to attract a shared pair of electron towards itself, it is decreases because nuclear charge decreases. Suppose you consider the last orbit, the electrons are present. So the proton carries positive charge, is unable to attract the last electron. So attraction power is very, very less. So electronegativity decreases top to bottom. Atomic size is indirectly proportional to the electronegativity, right? So in the group, electronegativity decreases on moving down the group. This is due to the effect of increased atomic radius. So it is mentioned in the graph, right? So lithium, sodium, potassium, rubidium, cesium. So top to bottom, first group elements, electronegativity decreases. So variation of valence in group. Variation of valence in group. So what is valence? In the last orbit, in an atom, how many electrons are present? That is called valence. Now we consider alkali metal. Group 1, lithium, sodium, potassium, rubidium, cesium, francium. The number of electron in valence cell 1. So valence 1. That's why the chlorine is bonded with lithium or sodium or potassium, rubidium, cesium means LiCl. Only one chlorine, it makes a bond with alkali metal. Lithium chloride LiCl, NaCl, KCl, RbCl, CsCl. Okay. Now the electronic configurations are given. So lithium, when we write the electronic configuration, is ended with 2s1. Sodium is ended with 3s1. Potassium 4s1. Rubidium 5s1. Cesium 6s1. Francium 7s1. So in the last cell, each element are having one electron, that is called valence. The combining capacity of the element, that is a 1. Now group 15. Group 15s, what are they? Nitrogen, phosphorus, arsenic, antimony, bismuth. Here the number of electron in the valence cell 5. Number of electron in the valence cell 5. But valence 3 or 5. 3 is possible, 5 also possible. For example, when we write the electronic configuration, is ended with 2s2p3. And phosphorus 3s3p3, arsenic 4s4p3, antimony 5s5p3, bismuth 6s6p3. The releasing 3 electron is possible and 5 electrons, both are possible. So 2p3 electron will come out or 2s2 electron will come out. That's why 3, 5 is given. Then phosphorus chloride. Suppose you take phosphorus chloride, PCl3 is possible and PCl5 also possible. Next, variation of valence in period, that is second period elements. Okay. In a period wise, now we are going to see the variation of valence. Lithium, we know that 1 electron, and valence combining capacity 1 electron. Beryllium 2, then boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, neon 8. But here we check the valence combining capacity of the element. Lithium 1, beryllium 2, boron 3, carbon 4, nitrogen 5, 3, oxygen 6, 2, then fluorine 7, 1, neon 8, 0. So why? Because when we write the electronic configuration, lithium ended is 2s1. Beryllium atomic number 4, so 1 is to 2s2. The last 2s2. That's why it is given. Number of electron in the valence shell 2. So combining capacity also 2. So beryllium chloride formula BeCl2. We should write it. Lithium chloride LiCl. Likewise the boron. Boron you see atomic number 5. The electronic configuration 1s to 2s to 2p1. This is ended with 2s to 2p1. So 3 electron are coming out. This is possible. That's why 3 is given. Boron chloride. Usually we can write BCl3. Then carbon 4. Carbon 4, 1s to 2s to 2p2. The 2s2, 2p2. The last orbit 4 electron will come out for making the bonding. That's why the methane, what's the formula? CH4. Combining capacity 4 hydrogen is bonded with the carbon, right? So nitrogen likewise 5, 2s to 2p3. So 5 will come out or 3 will come out. That's why 2 valence combining capacity of the element 5, 3, right? So oxygen 6, 2. So water, what's the formula? Oxygen is combined with the 2 hydrogen. So 2 is possible. Then fluorine 9, 1s to 2 is 2p5. Now the combining capacity, it attracts in the last cell 1 electron from the another atom means it is stable. That's why hydrogen is bonded with the fluorine. So combining capacity 1 electron. So neon is a stable. 1s to 2 is 2p6. The electrons are completely filled. So valence electron is 8. 2 plus 6, 8. But another combining capacity means does not occur because it is stable. It does not lose or gain any electron with another atom. So these are the variation of valence in period, that is second period elements. Now, what are the anomalous properties of second period elements? What are the anomalous properties? Anomalous properties means what? Different properties or exceptional properties. The first point, lithium and beryllium form more covalent compounds unlike the alkali and alkaline earth metal, which predominantly form ionic compounds. So lithium, beryllium maximum has more covalent compounds, but alkali, alkaline earth metal ionic compounds. These are the anomalous properties. So another one point, they have maximum covalence of 4, right? Whereas the other members of the subsequent periods have more orbitals in the valence shell, so higher valency. For example, so boron has 3 valency, Bf4 minus, right, will form the same group. Aluminium, suppose you take aluminium, so boron, aluminum, gallium, indium, thallium, that 13 group elements. Aluminium forms with the fluorine F6, it gives a 3 minus, because higher valencies. Higher valencies. So these are the exceptional anomalous properties of second period elements. Now, what are the elements exhibiting diagonal relationship? It is very, very important. 2 mark question. What are the elements exhibiting diagonal relationship? Diagonal relationship means what? Lithium, beryllium, boron, carbon. The second period elements, we have to take it, right? Now, then third period, sodium, magnesium, aluminum, then silicon. The second period and the third period elements, properties, some of the elements are having similar properties with the third period elements, second period elements and the third period elements. So what are they? Lithium, magnesium, beryllium, aluminum, boron, silicon, boron, silicon. Okay, here you can find the question, how do alkali metals and halogens react with oxygen and then water? Alkali metals, what are they? Lithium, sodium, potassium, rubidium, cesium, francium, right? And halogens, what are they? Fluorine, chlorine, bromine, iodine. So react with oxygen and then water. Now, here I have given alkali metal. So one of the metal, sodium. Sodium react with oxygen. Sodium oxide will form. Sodium oxide, Na2O. Then the sodium oxide further react with water. It gives sodium hydroxide. Strong base will form. Okay, alkali metal reaction is over. Then halogen. One of the halogen we have to utilize chlorine. Chlorine react with oxygen. Cl2O7 will form. Then Cl2O7 again react with water. Perchloric acid HClO4 will form. The sodium oxide is a basic oxide, it gives base. Cl2O7 acetic oxide, it gives acid, perchloric acid. Now, look at the equation. Is it balanced? No. The first equation we see, left side Na1, right side 2. So left side oxygen 2, right side 1. So how to make a balance? So left side we put 2 Na. Now sodium is balanced. Then right side only one O is there. So make it O left side only one. So off. 2 cancel. So we can balance the oxygen also. So 2 Na plus half O2 gives Na2O. The second equation, Na2O plus H2O gives NaOH. Second equation also unbalanced because left side 2 sodium, right side 1 sodium. So make it 2. Now you check remaining elements. Left side oxygen 2, right side also 2. Left side hydrogen 2, right side also 2. Second equation is balanced. Third equation, chlorine, Cl2, right side also Cl2. So right side O7 is here. So left side 7 by 2 O2. 2 cancel. So total number of oxygen 7. So Cl2 7 by 2 O2, Cl2 O7, right? Third equation is balanced. The last equation, Cl2O7 react with the water gives a perchloric acid. Left side hydrogen 2. So right side only 1. So make it 2. Make it 2. Now chlorine is balanced. Oxygen 2 into 4 8. Here also 7 plus 1 8. These are very important equation. How do alkali metals and halogen react with oxygen and then water? Next, prove that beryllium hydroxide BeOH twice is amphoteric in nature. Amphoteric in nature. Amphoteric means what? Beryllium hydroxide reacts with both acid and base. Acid and base. So which compound react with the acid and base? That kind of compound we can call as amphoteric. Amphoteric. So beryllium hydroxide react with acid, that is a hydrogen chloride, hydrochloric acid we can say. Then strong base, it reacts with the strong base sodium hydroxide. So when beryllium hydroxide reacts with the hydrogen chloride, it gives beryllium chloride and water. And the same beryllium hydroxide reacts with the strong base sodium hydroxide gives sodium perylate. The common name is sodium perylate, Na2BeO2 with water. Just you find these two equations are unbalanced, right? So make it balance. Make it balance. Beryllium left side 1, right side 1. Chlorine left side 1, right side 2. Now 2 HCl. Chlorine is balanced. Then hydrogen we count it. 2 hydrogen, here also OH2. So 4 hydrogen left sides are present. Then right side only 2. So make it balance. 2 H2O. Now oxygen also balanced. First equation is balanced. Second equation, right side Na2, left side only 1. Okay, first you balance sodium is balanced. Then hydrogen left side you count it, 2 hydrogen, beryllium hydroxide, hydrogen 2. So 4 hydrogens are here. Right side only 2. So make it 2 H2O. These two equations are balanced. This question is very important 3-mark question. Beryllium hydroxide is amphoteric. Prove that. Thank you.